recording. So for today, ang gagawin natin is modules on intersecting lines, pati sorry. Gagawin natin is intersecting lines and yung skew lines. No? In particular, sa skew lines, gusto natin mahanap yung tinatawag na shortest distance and shortest horizontal distance. Okay? So, intersecting lines is quite simple. Gagawin lang natin dito is how do we identify if two lines are intersecting? Okay? I'm assuming na you watch the videos na sinend ko. And yung sa videos naman, very, short lang naman yung discussion on, or very, simple lang yung discussion on how you are able to determine if lines are intersecting or not. But the basic theory is that, i-rundown ko lang, super bilis lang, no? The basic theory is that if they are truly intersecting, what happens is, yung intersection point nila is a shared point. Tama? It belongs to line 1, and it also belongs to line 2 if line 1 and 2 are intersecting. So meaning that if we can find that particular point and we try to project it downwards or try to project it onto the next view, because it's a shared point, it should be projected in the same projection line. Nag-make sense ba yun? Because it's a shared point. No? So if it is not located at the exact, or it is not located in the along the projection line, meaning that the two lines in question are not intersecting. Okay? So very simple yung the way we can determine it. Ang gagawin lang natin is we look at a particular view. It could either be we're looking at HRP or we're looking at FRP. Doesn't really matter. You will still get the same conclusion. No? So, let's say, for example, I'm looking at HRP and I'll try to project the intersection points dun sa baba, which is FRP. Okay? So, we have 3 apparent intersection points. No? Let's start with atong CD versus 1, 2, and 3, 4 muna. Okay? So, let's look at CD with 1, 2. CD and 1, 2. Tapos ang gagawin lang natin is, ipo-project lang natin pababa itong intersection point ng CD and 1, 2. And you'll notice that the intersection point, which again is a shared point, no, lies along the same projection line. If you look at the projection sa baba, makikita mo yung 1, 2, and CD also intersects along the same projection line, which means that they are truly intersecting. Okay? So in space, they are intersecting. Right? So, ganyan lang yung proof. It's as simple as that, no? Hindi ko lang may sinusulat pa ba dito as proof? Parang wala natang proof na sinusulat dito, no? I'm trying to remember kung sinusulat pa yun. I think wala nang sinusulat na proof, no? It's more of ganito lang siya. Just making a projection line. Right? So, next is, it's as simple as that, no? Let's check 3, 4, and CD. So, if you look at 3, 4, and CD, ito yung intersection point nila. Itong apparent intersection point na to. And if you move it downwards, if you make a projection line, you'll notice na iba na yung intersection point. Tama? The intersection point is located here instead of here, or instead of along this line. So, which means that 3, 4, and CD are not intersecting. Okay, because again, this is supposed to be a shared point. So, for example, if we try to name this point, let's name this point as point X. Point X should be along this line. Tama? Pero, why is it magically here? Parang nag-shift siya. And that breaks the rules for projection, diba? Sabi natin kasi, if we have a set of points or lines or endpoints or planes, etc., you can always project points using a perpendicular line to the fold line, and they should always lie within that fold line. Ito, parang nag-shift siya, meaning that posible na hindi talaga siya shared point. Kumbaga, si point X na to, point X along CD is here, pero point X along 3, 4 is here. So, which means that they are not, kumbaga, hindi shared yung point na yon. Alright? Unlike dito, kunwari, let's say, let's call this as point W, kunwari. Itong point W na to, which is shared by CD and 1, 2, point W is also located here, no? Which makes it a true shared point or a true intersection point. Okay? So hopefully that explanation makes sense. And you'll notice na hindi nagmamatter where you start. If you started from HRP, you'll conclude na different yung projection ng intersection point, which means na hindi sila intersecting. Or if you also start at FRP, wala dito, you'll make the same conclusion, no? Kasi ito yung intersection point nila. Let's just call it point Y kunwari. And you'll notice na magkaiba din yung location ni point Y. Nandito si point Y for CD, nandito si point Y for 3, 4, which means that they are not intersecting. So, again, doesn't matter kung ano yung pinili nyong view to check. You will always arrive at the same conclusion. Now, the problem is, when you have a case like this, no? Kunwari, if you try to project this, pagka ganyan, kung perpendicular yung isang line to the fold line, what happens is, you can't automatically conclude. Kasi, posible na yung intersection na to, let's call it V, itong intersection na V na to, is along talaga dito, pero there's no way for you to tell because the line itself is, is along the projection line. So, for this case, kailangan natin ng additional view pa. Okay? So, this is the only case wherein you need an additional view. No? For most cases, hindi nyo na kailangan mag-additional view. Enough na yung two views to conclude whether two lines are truly intersecting or not. For this case, gagawin lang natin is, let's just create an additional view. The additional view can be arbitrary, no? Kasi again, ang purpose lang naman ng additional view is that you show if they are truly intersecting or not. So, pwedeng gagawa lang ako ng random, arbitrary. You can create a vertical one if you want. I'll just create at an angle na para lang we can show it in action. So ito, this is FRP. Ito naman is ARP. Okay? Now, if I try to project this one, lang ha? Kailangan ko pala yung compass ko. Again, arbitrary lang yung ARP natin. Doesn't matter kung ano yung pinili nyong orientation niya. It will also always show the correct solution or parang same conclusion lang yung ma-arrive natin regardless of the choice. Okay. Just adjusting my compass. Okay. So, gagawin natin is let's project. So, from FRP and ARP, gagawa ko ng mga projection lines. And again, always remember, class, no, that when we create new views, the assumption is we always complete all views, no? So, kumbaga, that's an implicit na instruction, or it's always implied that you are to complete all views. Okay, so gagawin natin, kahit ang ini-inspect lang natin is si 1, 2, and AB, kailangan pa rin natin i-project si 3, 4, and CD because it is implied that we need to complete all views. No? Pero we can start with the lines in question lang muna. Ang lines in question is si AB and si CD. So, unahin natin sila. B is this distance away. Right? So, by now, you should be experts in line projections, no? So, 2 views away, 1, 2, 2 fold lines away, 1, 2. Ito, ARP. Yung orientation, yes, or arbitrary lang. You can also make it vertical now if you want. Most students, ang ginagawa nila, especially when given this problem, gumagawa lang sila ng vertical line, no? Pagka to show it. A, B, point B. Tapos A should be this distance away. Si A. Tapos si 1, 2 yung next, no? I'll have to create projection lines for 1 and 2. So 1 and 2. So it's here. 2. Tapos C and D. And lastly, 3 and 4, no? Okay. So, distance of C, 1 pala, sorry. Distance of 1 is this distance away. And point 1 is this one. And lastly, C2 is this distance away. Two. Okay, so let's check. Saan si 1, 2? 1, 2. That is 1. Ano? 1, 2. And ito naman si AB. Let's label B, A, 1 and 2. Tapos, let's check the intersection point, no? The intersection point is located here. Ito yung intersection niya sa ARP. And we can see that hindi sila nag-intersect, no? Tama? Ang intersection niya at this view is here, pero dito sa view na to, it's along this projection line. So, hindi nagtugma yung intersection points. Okay? So, again, so we can say na hindi sila intersecting. So, the only intersecting lines are, and since tinatang siya, intersecting lines are, ano yung nandito? It was CD and 1, 2 lang, no? CD and 1, 2 only. Okay? Parang ganyan yung final answer natin. Right? Again, I'll just complete all views, no? Kasi it's part of the problem. We always imply. It's always implied that we complete all views. So 3 is here. 4 is this distance. Tama, 3. Tapos next is, and we can also check dito, no? Let's check again CD and 1, 2. If they're truly intersecting, kahit pangatlong view yan, the intersection point should also still align, no? 3 and 4, and lastly C and D. C is this distance away. 1. So C. Lastly, D is this distance away. Oh, hindi ako gumawa. Let me create. C and D. C. Sorry. D. This is D. Ito naman si C. And lastly, ito yung 3, 4. Point 3, point 4. And just to double check, gawa tayo na projection line of the intersection of C and D. As CD and 1, 2, I mean. And if we did it correctly, oh, CD and 1, 2. Ito na. Medyo off ako, no? Slightly off yung akin. Pero konting-konti lang naman. Yung sa inyo ba, nag-align perfectly? So if you try to project W, it's here. Okay. Slightly off lang, pero I think it's good enough. You should be able to, accurately project this. Nagkamali siguro ako konti. Okay? So madali lang, no? Nakuha? Okay. Habol muna kayo. Gano'n ka off? Para mga ganito. So, kung off siya, it means na hindi gano'n ka-accurate yung mga projections mo. May nakakuha ba ng exactly, along the projection line, si point W? Itong intersection of CD and 1, 2. Again, if we did it completely accurately, dapat the projection line of the intersection points will always align. No? Okay? Right? So we can proceed to the next one. Again, very easy lang ang intersection. Intersecting lines are quite easy to to do. Next is let's determine if a plane is warped or not. Okay. I think I gave a preview on this topic before, no? Kung para din-discuss ko na only triangles are not prone to warping. So warping would look like this, no? So for example, if you have a triangle, because there are 3 points, and you draw the 3 edges of the points, ang mangyayari is, it will always be an unwarped plane, no? Pero, there are cases wherein if you have let's say for example, this quadrilateral, and I'll fold it in such a way na I'll fold it like this. Parang ganyan. This is called a warped plane, no? Na kumbaga, if you were looking at this in 2D, kumbaga wala kayong depth perception, and you will only see the 4 corners, this corner, this corner, this corner, and this corner. If those are the only 4 points na nakikita nyo in space, hindi nyo ma-determine kung warped siya or not when you are rotating it around. Parang mahirap ma-determine siya. Okay? Pero definitely, since we obviously see the paper that is warped, no? Parang hindi siya completely planar. Ibig sabihin, warped tong plane na to. So how do we check if it's warped? So we can use the concept of intersecting lines. Kasi if we try to look at this warped plane, tapos ang gagawin natin is, gagawa tayo ng 2 diagonals, kunwari. Then the intersection of the diagonals, if it's not warped, can be projected from one view to another. Tama? Pero kung warped siya, ang mangyayari dyan is yung intersection ng diagonal would shift around. Tama? So, gagawin natin dito, let's try it on this example, no? Try natin determine kung which of the 2 planes are warped or unwarped. Okay? Now, the easiest way again is to just draw 2 diagonals, pero it doesn't have to be necessarily diagonals. You can create your own, no? So for example, you can create 2 intersecting lines as long as you can accurately project those lines contained in plane A papunta dun sa pangalawang view, no, or sa PRP view. So from HRP, pwede kayong mag-project and then you can create those intersecting lines. Pero again, when you create your own lines, it is prone to error, no? Kasi posible na hindi nyo accurately na move yung endpoints ng new lines na kinate nyo. So, I always suggest to recycle points, no? And ang points na pwede natin i-recycle dito is the corners of the polygon. So, easiest way to do this is to just create 2 diagonals like this. Okay? We create 2 diagonals. Tapos, ang gagawin natin is, let's try to project the 2 diagonals. If they meet, or let's try to project the intersection point of the 2 diagonals. If they meet along the same projection line, then they are unwarped. So, ito, let's check plane A muna. And from here, kitang-kita ko na hindi siya nag-meet, no? Parang warp tong plane na to. So, ibig sabihin, this one is warp. Okay? So, check naman natin si plane B. So, let's do tapos, gawin natin is let's project the intersection point. And alam ko unwarped eh. And if I project this one, the intersection point lies in the same projection line. So meaning unwarped tong plane B. Okay? Now let's try to move one point. And para lang consistent yung sagot natin, let's say na this is point 1, this is point 2, point 3, and point 4. So this means that ito siya, this is point 1, point 2, point 3, and point 4. So para lang same tayo ng sagot, no? Let's move point 3 such that magiging unwarped na tong plane na to. Okay? So the easiest way to do this is, ang gagawin lang natin is, kailangan mag-meet yung intersection point. So the intersection point is this one. And since we're moving point 3, ibig sabihin na itong diagonal na to should be the one that's moving. Tama? So ang gagawin natin is, i-adjust natin yung diagonal such that the new diagonal now passes through the supposed intersection point, which is this one. Parang ganyan. And we know that the diagonal, that point 3 should be along this projection line. Again, yung projection lines natin should, or yung points natin should still follow the projection rule, no? Such that its projection line should be perpendicular to the fold line. So meaning, where the new diagonal meets the projection line, yun yung magiging new point 3. So this is now point 3. So, if we adjust, and let's just call it 3 star, no? To indicate that this is the new location of point 3. So 3 star should be the new location of point 3 so that the planes will become unwarped. Okay? Another way of parang sort of figuring out, this is still the best way to do it now. Pero if you want to quickly determine if a plane is warped or not, you just look at the shape of the plane. Okay, so take a look at this one, no? Si plane A looks like a parallelogram. Pero in FRP, nawala na yung parallelogram niya. Tama? Hindi na parallelogram si plane A. So parang yun pa lang, it's already a clue for you to determine that unwarped siya. Because if it's a parallelogram, di ba parallel lines should always appear parallel in all views. Okay? So ang mangyayari is, if you look at this one, notice how when we corrected it, by adjusting point 3, ang nangyari is 1, 2, 3, 4 now becomes parallelogram. Okay? And that is very important, class, no? Especially pagka nag-move na tayo to solids, kasi there are cases wherein we're rotating the solid and we want to determine if tama ba yung parang projection natin of that particular face of a solid. You always look at the shapes of the oblique planes. No? Later on, i-discuss ko what oblique planes mean. No? Pero if you look at different planes, it should always retain its sort of general shape. No? So for example, this looks like a trapezoid. Pag na-project siya sa FRP, it still looks like a trapezoid. Okay? Hindi siya foolproof na sure kayo na unwarped na yon just by looking at the shape, pero it's a clue for you na unwarped yung isang plane kapag it retains the same shape. So for example, if I have another example would be something like ganito, no? Kuwari, may parang shape that looks like a boot. Kapag nagro-rotate to around in space, never siya magiging parang hourglass yung shape niya. Para never mangyari to. 1, 2, 3, 4, 5. So, 1, 2, 3, 4, 5, 6, more than 5 sides pala to. Anyway, always, pag nagro-rotate to in space, ang makikita nyo is, pwedeng magkaiba yung proportions, pero it will always retain its sort of boot shape, no? Kapag iniikot nyo around in space. And that's true for, if you just look at your triangles, no, or try to look at different objects, kapag iniikot-ikot nyo around, it will always retain its general shape, no? Regardless of ano yung ano niya, orientation. Okay? So never siya magically magbabago into a different shape when it's being rotated around. So that's why that is a good tell if plane is warped or unwarped just by looking at the general shape. Dito, parallelogram. Then when it is projected in HRP, biglang hindi na siya parallelogram. So that shouldn't be the case. Okay? Pero again, you still need to do this to prove that two lines are intersecting or non-intersecting. Okay? So quite simple. Intersecting and non-intersecting lines, it's just projecting the apparent intersection point. If the apparent intersection point lies on the same projection line, then you are sure that the two lines are intersecting, and you can use that to your advantage to check whether whether planes are warped or unwarped. Alright? So okay na tayo dito. Let's proceed with the next part. And after this, let's do sample problems on intersecting and non-intersecting lines. Pero yung sample problems gawin natin through CAD na. Okay? Okay? Again, translatable naman yung mga techniques na ituturo ko dito sa manual methods dun sa CAD natin. Parang direct 1:1 lang talaga yung technique. Okay? So, this one is determining the shortest distance between two skewed lines. So, if you haven't watched the video, I'll just briefly explain what skewed lines are. Skewed lines are lines that are not parallel, pero they are not intersecting as well. So, if it's in a 2D plane, parang if lines do not intersect, it's automatically assumed that those two lines are parallel. Tama no? Makes sense. Kasi kung hindi sila nag-intersect in 2D space, then dapat parallel sila. Pero in 3D space, it can occur that two lines are non-intersecting pero non-parallel sila. A simple case for that is if you hold your pens like this, tapos, kunwari, they look parallel, tapos i-twist nyo lang siya around, no matter how much you extend these two lines, never sila mag-intersect. Tama? Pero, obviously na hindi sila parallel. Okay? So when you have a case like this, these are called skewed lines. And a good or two properties that we can find in skewed lines are the shortest distance and the shortest horizontal distance. Now, shortest distance, some may say na parang redundant siya, no? Calling it the shortest distance because the distance between two lines is always the shortest distance. Kasi when we are talking about distances, and I think I discussed this a bit dun sa parallel yung sa geometric constructions natin when we discussed parallel lines. Sabi natin that if we want to measure the distance between two lines, ang kinukuha actually natin na distance is the perpendicular distance. Yan lang. Hindi siya ganun ka... Let me just adjust, no? Mas lumabo ba? Let me just... Yan, okay na, no? Okay? So, when you have two lines, the distance between them will always be the shortest distance, no? And that shortest distance, again, is also called a common perpendicular. So, it's common perpendicular because the shortest distance will be a perpendicular distance to both lines. Okay? So, again, I'll leave the imagination to you guys. You can watch the videos or watch the yung sinend kong videos or the videos from the official na modules from College of Engineering. No? Okay? Pero in any case, I will just walk you through the methodology, yung manual step-by-step process when we want to determine the shortest distance between two lines. Okay? So, we have these two lines. They are skewed lines, meaning they don't intersect and they are not parallel to each other. What we want to do is, first, try lang muna natin hanapin yung shortest distance niya based on, how do you say this? Based on intuition, no? So, for example, if you have two skewed lines like this, ano kaya yung easiest way to find the shortest distance between them? Parang may narinig ako na point view. Tama? Pero ano yung gusto natin ni point view in particular? You try to think about it. Ipo-point view ba yung isang line? Pwede? Tama, no? Kasi kung naka-point view yung isang line, then since it only appears as a point, pwede natin kunin yung perpendicular distance from that point to the line. Tama? It makes sense because if it's a point view, tapos perpendicular yung distance na yon, then that is already the common perpendicular. Tama? Yun yung pinaka-intuitive approach, no, of doing shortest distance. And later, ipapakita ko yung other method, which is ang tawag nila doon is the parallel plane method. No? So, let's try to do it first here. Pwede natin gawin is, let's choose a line na gusto natin i-point view. And based on again, I always encourage you to just look first at the given. Tapos, try nyo i-determine kung ano yung what is the best solution route. No? Kasi for this case, we have two options. No? We can either make AB as the point and or 1, 2 as the point. Okay? So, try natin i-determine lang muna. Imagine lang natin. If it's AB, the true length will be somewhere, if we created a ARP here, tapos, we can create another line here, somewhere siguro pa ganyan siya, and we can have the final answer somewhere here. Okay? But if you try to do 1, 2, pagka ganyan, I think it will also work, no? Depending on ano yung itsura niya dito. So, I think, parang either ata, both solution pag ganun siya, it will leave. So, let's just randomly choose na lang. Ano yung mas gusto nyo? AB or 1, 2? Iba-iba yung sagot. Toss coin na lang natin. Let's do a toss coin. Wala akong coin dito. AB na lang. Randomly, let's choose AB as the... Or, what you can do is, half of the class do 1, 2, half of the class do AB. Or kayo na bahala pumili kung ano yung gusto nyo, no? Pero kung gusto nyo mag-follow along, sundin nyo na lang yung gagawin ko. I'll do AB. Again, I chose AB randomly, no? So, I'll just make a parallel reference plane here from AB. I'll make a parallel reference plane. Tapos, again, the parallel reference plane ensures that ARP1 has AB in its true length. Okay? And let's project. Bibitin na to. This one. That's point B. And lastly, si point 2. This is that. Okay? And I have to connect this one. Para may basis tayo for distances. This one and this one. And lastly, point 2. Okay? Right. So A is this distance away. A is this distance away. Okay. Then B is this distance away. Next is, hindi ko pa na nakonect si 1. No? One is this distance away. Tapos last is 0.2, no? 0.2 is this one. Okay. Alright. And let me just label first. This is HRP. And this is ARP. We'll have to do 2 views, no? So I'll just label it ARP1 na. AB is this distance. Okay. And 1 and 2. This is line 1, 2. Point 2 and point 1. And si AB yung true length, no? So let's label this as TL for true length. Okay? So after this, let's create the point view which is perpendicular to the true length. Tama? So let's make it perpendicular to this true length. Let's make it somewhere here. Comfortable distance away. Somewhere, something like this. So this is now ARP1 sa taas, ARP1 2 sa baba or sa right side. Right? And let's make our projection lines. AB and 1, 2. This one. Right? Tapos basis for distances is 2 views away, 1, 2. So let's measure from here. Let's measure A first. A and B should be the same distance away, no? Ito. A and B, because we made it such that it is parallel to the line. Dapat equal yan. This one and this one. Okay? Again, this is the point view of line AB. Should it be BA or AB? BA now, because B is closer to the reference plane. So this becomes BA in its point view. Okay? Now, lastly, let's measure the distance of 1 and 2. 1 is this distance away. 1 and 2 is this distance away. This one. This is 0.2. Okay? Ganyan. So this is 1 and 2. Okay? Now, ang gagawin natin is, now that we have line 1, 2, and we'll have line BA, or point BA, which is the point view of line AB, ang gagawin natin is, we create a perpendicular distance between them. Tama? So, we take a perpendicular distance, and that is now your shortest distance, or your common perpendicular. So, we'll align our triangles like this. Tapos, we'll mark the shortest distance or common perpendicular with a in my case, a blue pen. For your case should be an HB or the darker pencil, no? Okay, because this is considered as a final answer, this one. Okay, and we can mark it as SD. SD stands for shortest distance. Okay, so this is the shortest distance. Okay, so again, the shortest distance is a perpendicular distance, right? In this particular view, because BA is a point view, and we know that it's kumbaga, since this BA here is a point view and we know that it is a perpendicular distance, if you just think about it, parang BA is truly perpendicular to SD, and since BA is shown in its point view, it should make sense that SD actually here is shown in its true length. True length CSD here. Okay? And which also makes sense because again, di ba, pagka when we're doing perpendicular distances, dapat at least one should be in its true length for us to conclude that they are truly perpendicular. So etong 1, 2 na to, is not necessarily in its true length. So therefore, it must be the case where it's SD talaga yung naka-true length for the rules of perpendicularity to still apply, no? Okay? So ito, naka-true length si shortest distance and yan si 1, 2. Right? Now, ang gagawin natin is, we'll try to find, kasi SD is part of the final answer, no? So, kumbaga, SD is an object, is an object that should be drawn in all of the views. Okay? Kasi since we are completing all views, and when completing all views entails that you mark all the given, or you show all the given points and lines, as well as the lines that are being asked for by the problem. Okay? So, SD here should also be projected onto the different na planes. Okay? So, or not different planes, different na views, I mean. Okay? So, dapat, for us to show kung nasaan si SD, ang gagawin lang natin is, i-project lang natin yung endpoints ni SD. Okay? So, SD here, this is one of the endpoints of SD. So, nandito yung isang endpoint ni SD. This one. But how do you determine kung nasaan yung kabilang endpoint? How do you determine this other endpoint here? Okay, because if you look at it, this other endpoint matches with the, or aligns with the true length of AB. Okay, so there's no way for you to determine where the endpoint is. Tama? So, tingin nyo, ano yung best way to find it? Perpendicular distance. Tama, no? Kasi we know that in this particular view, si AB naman yung naka-true length. Tama? And again, since they are truly perpendicular and the only prerequisite for you to say that a line is truly perpendicular with another line is that dapat one of the line is in its true length. And in this case, in ARP1, si AB yung naka-true length. So meaning, if we were to create a perpendicular line from AB, passing through the point na nakita natin kanina, yung isang endpoint ni SD, which is here, this is now your SD. Okay? And I'll just mark this. Hindi nyo kailangan gawin to, no? Pero I'll just mark it with a perpendicular symbol para lang mas maalala nyo, no? Pero again, this is not necessary na ilagyan natin ng perpendicular symbol. Okay? So we have found ARP2, we have found SD in ARP2 and ARP1. Gagawin natin is, we'll just move backwards, no? So from ARP1, project it to HRP and FRP, etc., etc. Okay? So let's do the endpoint from, that's intersecting, by the way, some students, what they like to do is, instead of saying na this is SD, pwede rin i-mark nyo yung endpoints as, one of the endpoints as S, one of the endpoints as D. Para ganun. So, para mas intuitive yung kumbaga pag-project ng different points, no? So, it's still line SD kasi the endpoints are S and D. But it's easier to project it, no? It depends on you guys. Kayo na bahala which method you want, no? You can name the whole line as SD, or you can name each endpoint as one endpoint as S, another endpoint as D. Okay? Pero dito, since medyo sanay na ako sa project ng shortest distance, what I do is may mental note na ako which endpoint this is. So this endpoint belongs to line 1, 2. So I know that I'll project it hanggang line 1, 2. So this one. And this endpoint right here belongs to line AB, or is a shared point between the shortest distance and AB. Therefore, ito, project ko hanggang AB. Okay? Now that I've projected it, pwede ko nang i-connect. And I'll just mark it again. This is line SD for the shortest distance. And lastly, project natin siya pababa ulit. This endpoint is along line AB. So, project natin siya hanggang line AB lang din. Ito naman, this is along line 1, 2. So, let's project it up to line 1, 2. And now, we can mark this one. And we have successfully completed all views. So, this is the shortest distance again. Okay? So, you can imagine how shortest distances are quite useful in terms of engineering, no? Tama? So, if you want to, kunwari, save on materials and we want to make the shortest connection between, kunwari, two lines, then you take the shortest distance, tama? If you want to save up. Okay? If you want an easy imagination in real life, what this shortest distance might look like is, para siyang, if you take two lines, tapos connect it by a string, the shortest string that can connect the two lines na nakatot yung string na yon is the shortest distance. It's the shortest string that can connect both of the lines. No? Okay? Right? So, dito, na-imagine nyo, no? Yung parang string, how it is projected in space. Parang from ARP2, ganyan siya. Tapos, ARP1 is something like this, siguro. And you can imagine it rotating in space, no? Space, ito si SD. Right? So, that's how you do SD if you try to use the true length point view approach, no? Again, it's intuitive. You can remember this. And you can move either way, no? You can move from FRP to HRP, or pwede ring HRP to FRP, pwedeng pababa yung movement mo, no? Pero, again, because of the open space sa taas, kaya tayo gumawa from HRP. Right? So, next natin gagawin is, what we call as the parallel plane method, no? And for the parallel plane method, let's answer this question because this will give us a clue on how the parallel plane method works. If I ask you, if both of the skewed lines are in true length, what would the SD appear as? Okay. Try nyo lang imagine. Kunwari, yung imagination natin ito. Tapos gagawin natin na hanap tayo ng view such that in both views, naka-true length sila parehas. If naka-true length sila parehas, tingin nyo, nasaan si SD? Again, SD is a common perpendicular. It's perpendicular to both of the lines. So again, papakita ko yung pens, no? So ito yung pen natin. Ang view kung saan naka-true length to is something like this. Naka-true length sila parehas. Diba? So tingin nyo, nasaan ano yung, may unique orientation ba si shortest distance? Nasa endpoint? Di ba siya yung parang apparent intersection na naka-point view siya? Tama? It looks like a point view. Okay? So, in this technique hinges on that, parang property or theory na if we can find a way na gagawin nating true length parehas yung lines, where their apparent intersection is, that should be the location of the point of the SD that is shown in its point view. Okay? So, how do we do that? There are many ways to do this, pero the easiest way is what we call as the parallel plane method. So, in the parallel plane method, ang gagawin natin is, gagawa tayo ng isang plane containing one of the lines and make it such that it is parallel to the other line. Okay? So parang we have two lines. Again, you can just review the video no, for more details in this. Pero ito, bibilisan ko lang yung explanation. You have two lines. Gagawin mo is, i-contain mo tong isang line na to such that it is contained in a parallel plane. So, kumbaga, hanap ako ng isang parallel plane, nasasadyain ko, kino-contain niya yung line. And ito parallel plane na to, sasadyain ko siya na kaparallel niya itong other line. Okay, so it can be oriented in any way, di ba? Kasi it should contain. Pero i-orient ko in such a way na truly parallel siya dito. Now, if it's truly parallel here, and I take the edge view of the plane that I've just created, what happens is, automatic magto-true length din to. Because they are parallel. Okay? So what we do is, we encase one of the lines in a plane that is parallel to the other line, and we show the true size of the other plane, of the plane that we've just created. By showing the true size, we have exposed the true length here. And because it is contained, this line is contained in this plane, what happens is, kung true size to, di ba pag true size, all lines contained in the true size na plane is also in true length. So true length to, true length din to. So yun yung gagawin natin. Now the challenge is, how do we create the parallel plane? So to create the parallel plane, we first need to, naalala nyo kung ano yung unang view na kailangan before you can, to expose the true size pala. Ano yung unang view na kailangan before you can make the true size? Edge view? Edge view muna, di ba? So we need an edge view first. So to make our lives easier, ang gagawin natin is, the easiest plane we can create is a triangle, di ba? So the easiest na parang set of lines that we can do is, a triangle contains three edges. So we can make one of the line as the first edge. The second line, we make it parallel to the fold line para siya yung magiging true length sa next view. Kasi yung true length na yun, gagawin natin point view, which creates the edge view. Tama? So sasadyain natin na yung second edge would be the true length, so that it becomes the point view. Tapos yung third edge, ang gagawin natin is, sasadyain natin siya that it is parallel to the other line. So why do we need it to be parallel to the other line? Kasi di ba ang goal natin is to create the plane, we make the plane such that that plane is parallel, truly parallel to the other line. And the condition lang naman for a line to be parallel to another line is that the plane contains a line truly parallel to the other line. Tama? So, let's see it in action, no? We can draw it from here to here, or pwede rin naman from here to here. Doesn't really matter. I'm trying to imagine yung solution ko, no? Pagka nandito siya, dito yung line ko. Para pag ganyan. Tapos, I'm just imagining no, kung asan yung mas convenient. I think mas convenient sa 1, 2 tayo gagawa. 1, 2. Masyado malayo. So, pag AB din, masyado malayo yung 1, 2. Let me think now. Baka kaya. So, from AB dito. Let's try. Sa AB natin siya gagawin. So, what we'll do is, gagawa tayo ng first a line. Again, there are many ways to do this class, no? This is just my preferred method para kumbaga tipid tayo sa sa lines or sa nagre-recycle tayo ng points kumbaga. So what I'll do is I'll make the first line, this one, parallel to the fold line. So make it parallel. Tama? So si AC kumbaga yung parallel to the fold line para pag lumitaw siya dito, it's already a true line. Tapos next is I'll make the other edge, which is the edge BC, parallel to line 1, 2. Like this one. Tama? So BC here. So now we have found line BC. So complete na yung parallel. Ay no, sorry. Dapat hindi ko siya minark. I shouldn't have marked this with a blue pen, no? Dapat, since these are just construction lines, dapat naka-H pencil lang sila. So ito. So this is now ABC. ABC is a parallel plane. So we still need to project it dito sa taas to make it truly parallel, no? Pero ang ginawa ko lang dito is that if I write this down, no, BC is parallel to 1, 2 in FRP. Which means I need one more view wherein BC and 1, 2 appears parallel for it to be a truly parallel line. Tama? So, gagawin natin is, ipo-project ulit natin. So, si BC, nandito siya. And we'll take this one. This is line 1, 2. Tama? And we noted that we want BC to be truly parallel. Okay? So, I'll make this line right here, and this line right here makes it such that BC is the line BC is truly parallel to the edge 1, 2. Okay? So ang gagawin na lang natin to find the exact location of point C is we just project it using the line that we created at the bottom, no? Which is this one. We know that point C is here based on this first plane na ginawa natin at FRP. So we project it upwards, and where it intersects the second na parallel line na ginawa natin, that should be the location of point C. Okay? So, ito naman, I complete this. That is now line BC. And if you look at it from that, if we try to write down our proofs, we say that BC is parallel to 1, 2. Tama? BC is parallel, tama. Ito pala, sorry. This one. BC is parallel to 1, 2 in HRP, which means that BC is truly parallel to 1, 2, which also means that ABC is truly parallel to 1, 2. Again, this is just parallel lines and planes, so na proof. So we already know that the created plane is truly parallel. Is truly parallel to the given line. Right? Again, if nalilito, just review the videos that I've sent, no? Kasi nandun yung more in-depth na explanation. Right? So now that I have ABC, this one, ang gagawin natin is we will create we know that si AC is the true length. Tama? Because we made it such that it's parallel to the HRP, FRP. So, pwedeng si AC ngayon, yun yung basis natin for the ARP1 orientation. So, we make it perpendicular to this orientation. So, somewhere here siguro. Yan. And I'll say this one is HRP sa taas and ARP1 sa baba, or HRP to the left and ARP1 to the right. Okay? Now we can project line B and C. Okay? This point, this one is and Tapos, basis for distances will be 2 views away. 1, 2. Ito siya. Let me just complete this now. So that I have a reference point. Let me connect the endpoints. Like so. May kulang pa ba? Okay na, no? Okay? So now, let's measure the distances. Let's do AB first. A is this distance away. B is this distance away. One. And next would be lines 1 and 2 now. Line 1, 2, I mean. Points 1 and 2. So this point 1 or endpoint 1. And lastly, the endpoint number 2, which is this one. Okay? And if you did it correctly, automatically dapat you don't need to project point C, no? Kasi again, point C is not part of the problem. Hindi rin naman siya given, hindi rin naman siya hinihingi. So which means that point C, you don't need to apply the must complete all views for point C because it's not part of the given or the final answer. Okay, so you can skip it. Pero if you notice, if you did it correctly, the lines that you have created should be shown as parallel lines. Okay, so why is it shown as parallel lines? Kasi again, sinadya natin na si ABC is truly parallel to line 1, 2. Okay, and when we showed line AB, when we showed plane ABC in its edge view, dapat yung C12 will be in an orientation where it is appearing as parallel to line AB. This makes a lot of sense, no? Right? So, kumbaga, parang naka-edge view na si ABC dito. Ito yung kaparallel niya. Okay? So, now that we have this, quite easy. Ang gagawin na lang natin is we create a parallel reference plane. By creating a parallel reference plane, parallel to both lines, no? Yan, ito parallel sa dito, parallel din dyan. What comes out next is, because this is parallel to both lines, di ba kapag parallel to lines yung gagawin natin, it becomes a true length. So, which means that the next view will show both lines in their true length. Okay? So, ito, let's say ARP1. This one is ARP2. Okay? So now, let's just do some projections. If in ARP1, your lines do not appear parallel, then you did something wrong, no? Dapat, it should always appear parallel to each other. Because again, we did the parallel plane method and we made it such that ABC, yung imaginary parallel plane ABC natin is truly parallel to line 1, 2. Okay? So after doing this, if you projected line BC and line 1, 2. So this is the distance of line point B. Point B is this one. Point A is this distance away. And lalagpas ako sa page, no? Lastly, point 1 is this distance. and point 2 is this distance away. Okay? And extend lang natin to. Let me just mark the points first. This is 1, this is 2, this is B, this is A, so this is B, this is 1, this is 2, and this is A. Okay? So where they intersect, this intersection point, again, both lines are true length, no? This is true length, this is true length. Where they intersect, this intersection point right here, that is SD shown in its point view. Right? So now, gagawin na lang natin is we just project it backwards. So from ARP2, let's project it to ARP1. So, oops, sorry. Yan. From the intersection point or the SD point view, project lang natin. And where they meet, ito. This one and this one. That is the shortest distance. So tingin nyo, which of these lines are true length? Again, this is perpendicular. No? So one of them, or we have concluded that this is perpendicular. So one of them should be in their true length. So is it 1, 2, BA or CSD? Based on ARP1. Tingin nyo, which is true length? One, two. Pero true length si 1, 2 dito eh. So dapat TSD, no? Because point view siya dito. Diba? Pagka, when you're in the point view, any adjacent view will show the point view in its true length. Or will show the line in its true length in the adjacent views. So true length dapat si SD dito. Okay? And now, ang gagawin natin is, we can just project it backwards. No? So, project yung endpoints. This one. I'll project point SD. And I'll project the endpoint of SD here. That's intersecting 1, 2. Ito naman, project the endpoint that's intersecting AB. And now, I should have something that looks like not no. This is now okay. Hindi ganun ka-accurate yung gawa ko, no? Because take a look at this one. SD here is a true length, which makes sense na dapat, since true length si SD dito, SD should be parallel to this line right here. Pero nung pinroject ko, project it, hindi ganun hindi siya parallel, no? So, there are some inaccuracies dun sa ginawa ko. It should be, dapat ganyan eh. Try ko nga ulit. Ito nga. Hindi, ganun talaga. Okay lang. In your case, try to look at it. SD should, that's one check you can do, no? If you did it correctly and accurately, SD should be parallel to the fold line HRP ARP1. Again, because SD in its true length in this particular view. Ano yun? Ito? Sa mismong point 1? Patingin. Tingin ko may mali lang ako somewhere. Hindi ko mapinpoint ngayon kung saan ako na naging inaccurate. May nakagawa na accurate. Ang lumabas dito is parallel to this line. That should be the correct answer. Or yun yung pinaka-accurate answer. SD here should be parallel to this line. If it's parallel, ibig sabihin, sama yung ginawa. This method works just a small caveat, no? And I also explained this in the video, is that this method works whether you go from FRP, HRP, then ARP1, or pabaliktad, HRP, FRP, then ARP1. Okay? So, kumbaga, dito kayo gumawa ng parallel plane method, tapos dito nyo pinroject. From FRP, gumawa kayo ng ARP1. Pwedeng mag-work tong method na to, no? Either way, it can work. Pero, the next method na ituturo ko, the shortest horizontal distance, requires that you always start at FRP. So, parang FRP, HRP, then ARP1. Okay? So, the first two steps of the SHD method, which I'll explain later on, entails that you have the same first two steps, but it is required that you start from FRP. Hindi pwedeng mag-start ka from HRP. So that's why when students do this problem, ang ginagawa nila is they always start from FRP, then move to HRP, then ARP1, because you're sort of hitting two birds with one stone, no? Kasi you can get the SD from the next view, or get the SHD with another view. Okay? So, mamaya, I'll make that reminder again, no? But just keep that in mind. For SD, you can go either way, no? So, ang ginawa ko dito was I started FRP, then moved to HRP, then from HRP, gumawa ng ARP1. Okay? Pero if I did the opposite, I started with HRP, then moved to FRP, then created ARP1 from FRP, it's also permissible. You can do that. You can still find the same answer. Right? Okay? So, next, sorry. I-complete lang natin yung views, no? Let's complete all views. Yung endpoints ni SD. So, ito, SD here. This is along AB. So, hanggang AB. This one is along 1, 2. So, papunta sa 1, 2. Okay, and if you connect the two lines, the two endpoints, I mean, this endpoint and this endpoint, you should have the shortest distance here. Okay? Alright. Next natin gagawin is what we call as the shortest horizontal distance. Now, to imagine a shortest horizontal distance, this is the shortest distance wherein there is a constraint, no? The constraint is that, as the name implies, it should be horizontal, which means that it should be parallel to the ground, or in our case, parallel to the HRP, or horizontal reference plane. So, the way you check if you did correctly yung SHD is once you do the projections, if pagka lumitaw siya sa FRP, naka-horizontal siya, ibig sabihin tama yung ginawa niyo. Kung hindi siya nag-horizontal, somewhere along the way, nagkamali kayo ng sagot, no? Anyway, again, more details can be seen in the video. Just try to imagine, kailan ba useful ang SHD? Would you imagine a use case wherein you want to get the SHD and not the SD itself? Engineering scenario, mayroon ba kayo naisip? Kailan ba siya useful? Ano? Kailan useful yung SHD, yung horizontal distance? You get the horizontal distance and not the shortest distance. Again, si shortest horizontal distance is like the shortest distance, pero ang restriction niya is dapat siya yung horizontal siya, or kumbaga flat siya sa HRP, sa ground or HRP. A perfect example for this is bridges, no? So kunwari, if you're connecting to let's just imagine two roads that are separate mountains sila. Kunwari, nag-slope sila. So, skewed line sila. Tapos, you want to connect the two mountains together, you can use a shortest distance, no? Para least material possible. Pero kung ang shortest distance mo is, kunwari, this case, this is a shortest distance, and when viewed from FRP or the front view, naka-angle siya, no? No vehicle can make this type of angle. Tama? So for those cases, gusto mo na ang shortest distance mo would be a horizontal one. Okay? So it could be entirely possible that the shortest horizontal distance is also the shortest distance. There can be cases like that, no? Depending on how the two lines are created. Pero again, there is a merit for you to take the shortest horizontal rather than the shortest distance lang. Another example would be something like mga pipes, no? Water pipes, kunwari. And you want to connect two water pipes without using a water pump. If you try to do a shortest distance tapos it's at an angle, posibleng hindi makaakyat yung tubig because of the lack of pressure. So gusto mo pagka kinonect yung two pipes na yon, you want it to be flat para pwede pa rin siyang mag-run through the connection without an external pump aiding it. Okay? So, those are two. Siguro may maisip pa kayo na other examples, no, in your field. Baka may naisip pa kayong iba. Pero, shortest horizontal distance is also an important na parang line that we want to locate when we are talking about skewed lines. Okay? So, ito, mahirap siya imagine kung o kumbaga hindi masyadong intuitive yung steps in taking the SHD, pero ang goal lang natin is that the distance that we have created should be horizontal and it should look parallel to the fold line HRP FRP. So dapat dito lalabas siya na naka-horizontal siya dito. Okay? So the way we do it is it's still through the parallel plane method. So we still need to do this. Ganito yung first two steps natin. Pero instead of creating a line that is parallel to the SD, parallel to the two given lines, ang gagawin natin is we create a auxiliary reference plane that is perpendicular to the ARP1. Okay, yun yung gagawin natin. So yun lang yung difference. So kung ito yung step 1, if this is step 1, this is step 2, this is step 3, ang difference lang would be sa step 3. Step 3 for SD is creating a auxiliary reference plane. So ARP2 is parallel to the given lines. If you're looking for SD. Pero pag SHD, ang step 3 nyo would be ARP2 should be parallel, so should be perpendicular to ARP1. So, yun yung difference. Okay? So, hopefully that's clear, no? ARP1 being this one. So, ito kasi yung si ARP1, no? So, perpendicular siya dito. Yung gagawin nyo. Okay? For same first two steps silang dalawa. First two steps is the same. Ang difference lang is si step number 3. Gagawa ka ng perpendicular dito. Pero, again, I'll repeat this kasi a lot of students make this mistake. When you're doing SHD, it is required that step 1 comes from HRP. So, pagka SD, sulat ko dito. Pag step SD, step 1 should be at HRP for SD. Pero for SHD, for SHD yon. Step 1 should be at HRP. Required na dito yung step 1 mo. Hindi mag-work yung method na to, itong SHD, if your step 1 is not at HRP. It's because of the fact that you want it to be horizontal. So, kaya nagsisimula ka sa HRP, sa horizontal reference plane. You want it to be horizontal. But for SD, step 1 could be anywhere, no? Could be anywhere. Okay? Ito. Could be anywhere. Ito, step 1 should be HRP. Yun yung difference ng dalawa. Again, could be anywhere could mean that you can start from FRP, you can start from HRP. Kung given kayo ng PRP, you can also start from PRP. Doesn't really matter. Pag SD yung hinahanap, step 1 could be done anywhere. Okay? Pero for SHD, step 1 should always be at HRP. So, which means that, if you're smart, no, tapos parang tinanong kayo for a particular problem, you are asked both SD and SHD, it would be beneficial for you to start at HRP kasi you're hitting two birds with one stone. Makukuha mo na yung makukuha mo na yung SD by doing step 3 parallel to the given lines. Tapos makukuha mo rin yung SHD by doing step 3 perpendicular to the ARP1. Okay? So, I can't stress that enough, no? Parating, yun yung nakakalimutan lagi ng mga students. So, always remember those. Okay? Sige, start tayo dito. Dito, determine daw natin both CSD and SHD of the given lines below. So, we start with the same two steps. Pero again, we start at HRP because now we are required to get the horizontal distance. So, as a HRP tayo lagi mag-start at step 1. Okay? So, since we're starting at step 1 dito sa HRP, this requires that we create the parallel plane dito sa FRP natin siya i-create. Okay? So, kumbaga ito yung para step 0 natin, yung preparation natin. Okay? So, paano ulit? Ang gagawin natin is to enclose one of the lines in a parallel plane. So, we can do AB, no? Pwede, si AB. Ito yung ilagay natin inside a parallel plane. Tapos si 1, 2 yung mag-act as the line. Right? So, kung enclose natin to in a parallel plane, we can create a line parallel like so. Ganyan. Parallel to the HRP, FRP fold line. Tapos, itong 1, 2 naman, we make it parallel. Starting from point B, gagawa tayo ng parallel line. Like so. Ito, this should be parallel to this one. So now, we have, you don't always have to write the proofs, no? Pero, I'll just write it down para alam natin kung paano natin ginawa yung parallel plane natin. Yung imaginary parallel plane. Kumbaga. This is point C. So, we made it such that C1, 2 is parallel to BC in FRP. And we'll make it again such that 1, 2 is parallel to BC in HRP. Para 1, 2 will be truly parallel to BC, which also means that 1, 2 is now truly parallel to triangle ABC. Hindi ko na nilagay yung mga symbols, no? Pero ganyan ko na lang siya sinulat. Right? So, let's project it. Ito. And while I'm projecting the lines, ang gagawin ko din is I'll also connect the endpoints as well, no? Kasi I'll be getting the basis for distances later on. I'll be careful this time para accurate yung gawa ko. I'll do it a little slowly or a little slower. Ito naman, point C, move it upwards. Tapos, again, we want BC to be parallel to line 1, 2. Tama? So, line 1, 2 is this one. Wait lang. Hindi kaya. Mangyayari is, medyo pangit, no? This is line 1, 2. Okay lang. This can still work. BC would be this one. Sorry. Parang ganyan. So, this is line 1, 2. And it should be parallel to BC. Pero since if you move upwards, hindi na siya mag-intersect with the projection line. So, you should move downwards, no? But the problem is, if you're moving downwards, nandito ka na sa, no? Lagpas ng, this can still work. Ang mangyayari lang is, you'll have sort of negative distances, no? Feeling ko mas malilito pa kayo doon. A negative distance will be, instead of measuring from the fold line, sa opposite direction kayo magme-measure. Which I don't recommend, no? Parang feeling ko, mas lalo kayong malilito. So, pili na lang tayo ng ibang orientation. I think mali yung... Kasi nandito kasi siya eh. Let me see, no? Maybe we can... Kuha ko ng isa pa. Redo ko to. Pwede yung burahin yung nagawa nyo, no? I think masyadong mahirap yun. It's still possible to do it that way. Pero mangyayari lang is it involves negative distances from the auxiliary reference plane, no? Which can get a little bit confusing. So, ang gagawin natin, let's do it such that ang plane ngayon is contained in 1, 2, 3. Para 1, 2, si 1, 2 yung i-contain natin in a plane. And gagawin natin is let's contain it. But this time, kasi again, di ba ang ginawa natin before was that si C is perpendicular. Or sorry, parallel to the fold line. Pero if you try to force it that it's parallel to the fold line, what happens is sobrang layo ng intersection nila. So, gagawin natin is, i-connect lang natin arbitrarily ngayon. Pero, pagka ganon, hindi natin matitake advantage yung fact na may convenient tayo na true length. We'll have to create our true length. Pero, kaya pa rin naman, di ba? Kasi in any view, you can always create a true length. So, for this case, ang gagawin natin is, let's just make an arbitrary na edge 2, 3. Hindi naman magbabago yung solution natin because again, we can always create our true length. Pwedeng ganito. We can just create 3, 3 prime as the true length. You will still be able to project the parallel plane onto the ARP1 such that magiging parallel yung both lines or magiging edge view si parallel plane method. Okay? So, okay lang to. This plane 3 right here or si point 3 right here. Again, arbitrary lang ginawa ko. Yung location niya, it's still possible because if I created 3, 3 prime, like so, ito, 3, 3 prime right here, 3 prime can be projected upwards and it will be act as the true length. Okay? So, okay lang. Alright? So, gagawin natin is hahanapin natin yung location ni point 3. Location of point 3 is, should be somewhere here. Pero, si line 1, 3 should be parallel to line AB. And mukhang same problem pala. Same problem. Nandito yung location ni 1, 3. Masyadong malayo. Mukhang ang solution is dito dapat tayo mag-create para mag-opposite siya. Tama? Dito tayo mag-create ng point 3 dapat. Okay? So, erase. Delete ko lang to. Huwag nyo napansinin yan. Dito ako mag-create ng point 3. So, this is parallel. Meron pa ba akong extra? Wait lang. Do I have an extra? Yun na ata yung extra ko. Okay lang, pili ko ma-figure out ko siya. Okay, try lang natin. So, ang gagawin ko is I'll make point 3 dito sa side na to. Okay? Dito siya sa kabilang side. So, point 3. And I'll make it an arbitrary distance like this. So, now, I can project point 3 dun sa kabila. And hahabaan ko lang tong HRP, FRP fold line. Like this. I think this is the best way we can do this, no, para hindi siya lumagpas. Kasi pag ganito, mag-opposite na direction ni point 3. Okay? So, this is now point 3. So, ang gagawin natin is to find the location of point 3, we'll just make a parallel line from point 1 that is parallel to AB. So, ito siya. This one. Right here. Okay? So, ito siya. Okay? So, just so we remember the proof, ang ginawa natin is si line 1, 3 is parallel to line AB in FRP. And also, line 1, 3 is parallel to line AB in HRP. Therefore, line 1, 3 is parallel to line AB. And because AB is contained in ABC, we also say that line 1, 3 is parallel to plane ABC. Okay? So, yun yung ginawa natin. Now, what we want to do is, let's create a parallel na true length or parallel line so that we can create a true length. And I'll just make 1, 1 prime as the parallel line to the fold line. So now I can project 1 prime. This now becomes a true length. So, true length. Check ko lang, no? Gano'n ka malayo. Wala. Tama itong ginawa natin. Okay? So, notice, class, no, na si plane 1, 2, 3, yung only purpose lang talaga niya is to find the orientation of ARP1. regardless of what parallel plane method you use or what parallel plane you arbitrarily use, as long as it is truly parallel to AB, you will always get the same ARP1. Same ARP1 yung makikreate natin. As long as, again, you satisfy this condition that the parallel plane that you've created is truly parallel to the other line. And even if you do it the opposite way, no? Kunwari, gumawa kayo ng isang parallel plane containing ABC. Kunwari, ang ginawa nyo is, ito yung kinontain nyo in ABC, and you found a way to make it truly parallel to line 1, 2. Ang lalabas dyan is same tayo ng ARP1 position. Okay? So, ang purpose lang talaga ni parallel plane is to find this true length, and this true length gives us the orientation of ARP1. Okay? So, from this true length, if I create this one, ayan, and I can make it, I'll make it closer a bit, no, kasi baka kukulangin ako ng space. I'll make it closer. And okay lang na kahit matamaan ko yung 0.3. 0.3 ko kasi again, 0.3 is not part of the solution. Or no, sorry, not part of the final answer. So kumbaga, it already did its job, no? So, not necessary na na i-project ko pa siya in the other views. So, I can have something like this, and this is now ARP1. This is HRP. Okay? So, if I project this, ang ipo-project ko lang is yung original lines lang, or the given lines, which is 1, 2, and AB. So, first project 0.1, sorry, 0.1, then point A, then point 2, lastly si point B, which is this one. Okay? Eh, mukhang kailangan ko pang layuan to, no? O baka enough na to. And by the way, I need to connect this, no? So that I have the basis for distances. Endpoints. Point 1 and point 2. Okay? So, let's try to do it. Ito. This is distance of point B. B is here. This is the distance of point A naman. This short distance. Siya. Let's mark it. A, and last is the point 1. Point 1 is this distance. Point 1. Point 2. This distance. Point 2. Point 2. Okay. Point 2, point 1, and we have point A, and point B is, let's go B, this one. So again, notice I'm not anymore, I don't know, concerned with point 3, because point 3 again is just there to provide me the orientation of ARP1. Once it has done its job, hindi mo na kailangan i-project siya. And if I did it correctly, dapat in ARP1, both lines should appear parallel. And parang tama naman. Okay. Slightly off lang konti. Okay? If it didn't appear parallel, again, yun yung isang already an indicator that you did something wrong, no? Or mali yung parang projections nyo or measurements nyo. At ARP1, both lines should appear parallel to each other. Okay? If hindi sila nag-appear parallel, then you need to redo what you have done, no? Okay? So, let's start. We've already done SD. Pero we can do SD again here, no? Pero, let's try to do SHD first. SHD muna tayo before we do SD. Okay? So, SHD, ang sabi natin, di ba, pagka SD, it's parallel to the two lines. Dito tayo gagawa. And I'll just mark it here as early as now, no? Mark ko lang dito. So, dito, ARP 2, ARP 1. So, here, ARP 2 should be parallel to the given lines. That should give me SD. Okay? So, sulat ko lang dito. This gives me SD. Okay? I-doubt pala minato. Medyo okay lang yan. Pero pagka gusto ko gumawa ng SHD, ang gagawin ko is I'll make it perpendicular to the ARP fold line. Ito siya. Make it perpendicular here. So now this is ARP 3 and ARP 1. Okay? Ang ganun. If I do it perpendicular, so ito, just to show you, ito yung perpendicular, no? Perpendicular um, yung new reference plane ko. Okay? Common mistake here, class, no? Kasi nalilito yung mga students. Sometimes, ang ginagawa nila is, they remember the perpendicular parang requirement, pero instead of making it perpendicular to the fold line, ginagawa nila is perpendicular to the line themselves. Which gives you the wrong answer, no? Hindi nyo makukuha yung HRP as SHD that way. Okay? So always remember, parallel to the lines if SD, perpendicular to the fold line if SHD. Okay? Sulat ko ba dito? Lagay ko na lang. Fold line. Okay? Okay? Right? By the way, I'm using ARP3 dito kasi dinenote ko na si ARP2 for my SD. So kaya ARP3 to, no? You can't name two views with the same number. Kailangan unique sila na number. So since ito na yung ARP2 ko, ito yung magiging ARP3 ko. Pero pwede naman, if you did this first, then you call this as ARP2, pero which means that this now becomes ARP3. Okay? Sorry. Pagka again, hindi nyo pwedeng i-name yung same view or different views with the same number. So ito, this is ARP2 to create the SD. I named this as ARP3 to create the SHD because I've already, kumbaga, taken up na yung name na ARP2. Okay? Malinaw yun, ha? So, dito sa instruction ko, yung pinakita ko kanina, this one, I'm calling it ARP2 here because I'm assuming na hindi nyo ginagawa yung CSD. Pero when you're doing SD now, kailangan definitely different na number to, no? And just to show you, lagay ko na lang star kasi baka ARP2 asterisk to show na may caveats din yan. Okay? Okay. So, dito na tayo. Let's do SHD first. So, gagawin natin is pro-project lang natin siya. Okay? 2 views away. So, 1, 2. Ito yung basis for distances. So, we get the distance of 0.2. Point 1 would be this distance away. Point A is this one. Bala ka sila. And point B is this distance away. So medyo malayo si point B. Okay? Ay. Tapusin lang natin yung SHD. Kahit SHD lang muna. Tapusin natin. And just take a short break. Okay? So, this one is what's the point A? This is point A. This is point B. Oh, sorry. Point B is here. Ah? Hindi, dito. Okay, sorry. 2 views away. So, 1, 2. Oh, pero ARP3 comes from 1 eh. Eto? Well, separate kasi sila eh. So, kumbaga, they are not adjacent na views, no? So, ARP3 is not connected to 2. So, hindi siya manggagaling sa 2. Kumbaga, ang connected sa kanya is ARP1. So, dapat ARP1, then HRP. Technically, pwede rin ARP1 to ARP2. Pwede rin yun kasi 2 views away sila. So, 1, 2. Pero wala namang laman dito eh. So, hindi natin magagamit. So, dito tayo kasi siya yung may laman. Okay? So, 5.1. Sorry, 2.2. 0.2 ito. Okay? I-zoom in ko to kasi important to, no? What you'll notice with this problem is that wait lang ah. Okay na yung zoom, no? Ay, yung focus. What you'll notice with this problem is that hindi actually nag-intersect si A, B, and si 1, 2. Tama? Unlike the one we did before, eto, clear yung intersection point ni A, B, and ni 1, 2, which means that SD here is in its point view. Here, hindi na sila nag-intersect. And if you try to do this in CAD, kahit sa CAD, hindi siya mag-intersect talaga. Which means that the true SHD lies outside of the given two lines. So what that means is para siyang, if you try to imagine your pens again, pwedeng yung SHD niya, kunwari ito yung two pens natin, pwede ang SHD is connected somewhere dito pa. Kumbaga nasa malayo pa siya na distance. Okay? So parang if this is 1 A, D, and kunwari nandito si 1, 2, no? Ito na yung ARP2 natin. ARP2, I'll say asterisk. Kumbaga yung second view after ARP1. Kung ganito yung case, 1, 2, what you'll have to do is you'll have to extend this one para mag-meet sila. Kasi kung saan sila nag-meet, yung extension na yon, nandun si SHD, shown in its point view. Okay? So, kumbaga nasa malayo siya. Alright? Na-imagine ba to? Kung paano siya in real life? Para siyang, think of a retractable na, ano no, na tawag dito. Para, para sa teacher, yung retractable na gano'n. Tapos, ang nangyari is, you connected that with a string dun sa isang line pa. So, meron silang SHD. Pero ngayon, ang ginawa mo is, ni-retract mo siya kasi it's lower. The string will be somewhere, if it's truly a SHD, nandito siya somewhere dun sa parang imaginary line na yon. Okay? But because eto siya, yung line natin is smaller than where the SHD is supposed to be located, kaya kailangan mo i-extend siya para mahanap yung true SHD niya. Okay? To get the horizontal distance. Pero in this case, technically, pwede yung isabihin na the SHD does not exist. Kumbaga walang shortest horizontal distance sa problem na to. Because, yun nga, hindi nag-extend. Pero, in ES1, we treat lines as segments lang kasi. So, it represents a larger line or a more infinite line. So, we can very well extend this line para mahanap natin yung SHD niya. Okay? So, in our case here, it's very small, no? Sobrang liit lang ng kumbaga yung bitin siya. Pero it's enough para masabi natin na outside of the lines yung SHD. So we'll have to extend this one. So I'll extend point 1 like so. Parang ganyan. Kung saan sila nag-intersect dito, yan yung SHD. So this point right here, sorry, zoom out ko konti. So yung extension na yun, kung saan sila nag-intersect, yan si SHD. So, ito si SHD, and that is shown in its point view. And from here, we can work our way backwards. So, tulad ng ginawa natin sa SD kanina, let's work our way backwards to find the SHD. Okay? So, notice how C1 yung in-extend natin, no? So, ito, i-extend din natin C1 dito. Kasi we'll have to extend this as well. Yan. And now, we can make the projections. Okay, ito, project natin backwards. Ito siya. Very small lang, no? Ito. Yan. So, ito, this line right here, this is now your SHD. Okay? Which is, again, in its true length, no? It's true length because naka-point view sa SHD dito. So, nandito si SD. Okay? Now, let's try to okay? So, now, pwede natin siya ibalik. If we did it correctly, pagkadating natin sa FRP, it should be parallel to the HRP line. Okay? So, ito, move lang natin. This is along AB. Ito. Then, we'll have to extend line 1, no? Ng konti. Dito. And so this is SHD. And this is the moment of truth, no? If accurate yung gawa natin, and let's see, I'll extend the line 1 first. No? If we did it correctly, dapat magiging horizontal ito. And mukhang tama naman. At least in my case, no? Notice how naging horizontal siya. Okay? Shortest horizontal distance. It's parallel to the, ano. Okay? Sa inyo ba? Nag-horizontal ba? Dapat horizontal siya. Again, para yan to interpret. Yun yung ultimate check, no? Kung hindi siya nag-horizontal, kasi somewhere along the way, tama niya kayo. It should always be horizontal. Yes. Again, this is a sort of a difficult problem, no, because it requires an extension. Pero, yung ibibigay kong plate, i-make sure ko na hindi nyo kailangan mag-extend. Hindi nyo naiisipin yung extension. SD, mamaya na lang natin gagawin yun. Let's take a short break. Balik tayo 3:50, 10-minute break. SD, kayo na gumawa. Okay, pinatay ko na dito. Kasi pinatay ko na dito. Yun yung ginawa ko dito. Hindi lang super obvious yung nagpa-block yun. Pero yan, nandito yung kwarto. Extend ko pa. Ay, di ba? Nandito yung kwarto. Extend ko pa. Nag-block lang kasi kaya buka siya. Nag-connect. So, in-extend ko. Kasi ganito yung sa... Ito siya. O baka malito na tao. Ito. Hindi ba ikaw to?
Periodic UIORE. Ako yan sir.
Invite ka na. Email ko na lang ulit. I-send ko ulit. Eh? Baka, parang iba nga. Inulit ko, naging buo yung pangalan. Okay ba to? May number ka ba? May number? 1 ka ba or 2? Delete ko na lang to. Yung una. Sabi nga kung Lumabas.
Wala po.
Oh, sige. Favor naman. Ano bang bukas pa rin take home yung plate kung gusto nyo. Ganun ulit yung arrangement ha. Pag take home, wala akong excuse na tatanggapin. Oo, bawa. Basta kung take home. Pero pag nandito kayo, tapos nag-brown out dito, di pa rin kayo mag-extend kung nandito kayo, no? Pero kung take home, nag-brown out sa inyo. Gano'n naman sa, ano, sa schedule natin. Pero hanggang perpendicular. Oo, hindi to kasama. Okay, gawa tayo ng sample problem. Open nyo yung ito, may sa tiny URL natin. If you forgot, it's tinyurl.com/ES1CAD. Okay. It's saved under worksheet 7. WS7 channel. So ito, naka-AutoCAD na. No need to import. DWG file na siya. You should directly be able to access it. No? Okay. Now this is an old plate. Let's try to do this. Relatively easy lang naman to. We should be able to finish by 5, no? All of the 3 windows. Okay? So let's start. Ito muna, determine the common perpendicular between lines lines KL and RJ, then measure the shortest distance and complete all views. Okay? So for this problem, the common perpendicular is just the, I don't know, shortest distance. Right? So, the easiest way to do this is we can use any technique that we want, no? Pero perhaps the easiest one we can do is to just ngayon lang nagbukas. Wait lang ha. Close ko lang to. Perhaps the easiest way to do this is to look at the lines themselves and let's parang conveniently KL is already parallel to the fold line, no? Which means that the easiest way to do this is to do the point view method, no? Kumbaga, ipo-point view natin yung isang line. And since naka-point view yung isang line, kaya natin makuha yung perpendicular distance nila. Okay? Tapos, pag nakuha na natin yung perpendicular distance, we can just move it backwards or parang we can just project it to the adjacent na mga views available. Okay? So, in this case, ang gagawin natin is, I know KL is a true length and let me just lock it, no? When you have problems like this, again, always lock your given layer para hindi nyo siya magalaw. Add a construction, mag-add ako ng construction layer. I'll color it magenta. Then, like before, I'll add a final answer layer. I'll color it with index, itong index 5 ata tawag nila ito. Index 7 pala. Index 7. Tapos, I'll make it a little darker, no? 0.3 siguro. And the construction lines, gagawin ko siyang 0.13 para mas manipis siya, no? Again, personal preference lang yun. You can format it any way you want to. Okay? So, okay. Sulat lang natin muna. I think in this instance, 0.1 nga ata yung best na, ano, no? Parang height for your text. Okay, so I'll just write it down. Ito, I'll just say na naka-true length ito. Okay? Ano yan? Line? LK, yeah. Kasi si LK yung nakaparallel sa FRP to PRP. Okay? So, since naka-true length to, we can just create a perpendicular reference plane, no? And I'll go to the construction lines layer para pwede ko i-extend itong LK, creating a parallel line. So, para pwede tayong gumawa ng perpendicular reference plane. And let's go to final answer. Gawa tayo ng perpendicular ARP. This one. And I'll do L weight. Let's display the line weight. No? Okay. Tapos, from here, since this is already a true length, one additional view lang actually kailangan. No? But before that, let me label um, my reference planes. So, I'll label this as ARP sa taas, then PRP sa baba. Okay? Move back to my construction layers. Measure natin yung mga distances or gawa muna tayo ng mga projection lines like so. So, and we can measure distances. So again, I'll do the trick where I can measure direct perpendicular distance using my circle tool. No? As long as lumabas yung perpendicular symbol, I know that it's a perpendicular distance. So this is the distance of K. I'll just trim it. And this is also the distance of L, no? Because naka-point view na siya. So let's mark it with a point with PO. I'll change the P type to the crosshair that's going to 0.1 and in absolute units. So I think this will be a perfect size. To. And lipat ko to sa final answers na layer. So I have, and while I'm here, label ko na. This is line KL na siya, no? Because K is closer to the reference point. So it's KL, which is in its point view, no? Okay. And I'll also move this to the final answers. No? And galawin ko lang konti para hindi siya magulo. Then let's measure distance of R, which is this distance. I'll trim this down. Then next is measure the distance of J. J is this one. And also, I'll just trim this down. And mukhang pwede ko ilipat to dito. No? Okay. And using my final answers layer, pwede kong i-connect ito. And now that's my line RJ. This is R. And this is J. Okay. Now, using a line, I can make a perpendicular line passing through the point view KL, moving towards line RJ. So that's perpendicular. So, ito ngayon, I'll just mark it. I'll say this is SD, no? Okay. Mark it. I'll say this is SD. Eh, pwede ko ilipat konti. Okay, so that's SD. And to be more accurate, SD siya, who is also in its true length. No? Okay? Again, ito mga labels na to are part of the solution, no? So you'll need to always specify them. Okay? Move ko lang to si KL. Okay? Probably, I'll make this, ano, no, para kasya siya. Gawin ko na lang ganyan. Hindi ko na i-rotate. Okay? So, this is SD. Now, to find the endpoints, ang gagawin ko lang is i-project backwards yung endpoints ni SD. So, the first endpoint will be this one. Si endpoint that is connected to RJ. So, make a projection line. Connect it to RJ like so. And lipat ko lang to dito. So, that's the first endpoint. And to find the other endpoint, itong point na to, what we'll do is we'll create a perpendicular na distance, no? Because KL here is in its true length. Therefore, again, tulad ng ginawa natin kanina, we can find the shortest distance by creating a line that is perpendicular to KL passing through this endpoint right here. So, parang ganyan siya. We can create something like this. So, zooming ko lang para mas malinaw. I'll make a perpendicular line like so. Okay? So, now, this small line right here, this is what we call as um, the SD. Now, because this is a small, no, I'll teach you a trick. This is called a leader line. And I think we can create it through Q leader, no? So, tapos, point lang natin to we can make it nearest neighbor, no? So, host snap override, nearest, tapos lagay lang natin dito. And we can say, yan, something like that. And let's say, this is SD. Text with 0. Parang ganyan. Parang ganyan. Totally optional. Kung ayaw nyo naman siyang gawin, pwede naman, ano lang, sulat nyo lang yung SD somewhere dito. Ang ano lang dito, hindi kasi obvious, no? Especially for distances like this na very small na. Hindi obvious. You might want to do a leader line. So, the leader line again is QL yung command niya or pwede ring M leader ata. MLD. M leader will also work, no? Hindi ko lang alam anong difference ng one. Okay. M leader creates a sort of angled na ano, no? So, okay din yung M leader. So, we can do M leader. So, M leader is MLD. Tapos, para ma-snap ko along the line, pwede kong gawin is right-click, then O-snap override, and I'll choose nearest para pwedeng i-snap ko lang dyan. Then, I'll place it somewhere dito siguro. Parang ganyan. Then, I'll change this to 0.1. Works well here. And I'll change, and I'll say SD siya. Something like this, no? So, it makes it a lot cleaner yung solution nyo if you use a leader line. But again, leader lines are not necessary. Pwede naman ilagay nyo lang sa tabi yung SD. Okay? Tapos kung gusto nyo, pwede rin kung nalalakihan kayo dito sa leader line na to, we can scale it down, no? Instead of yung arrowhead is 0.8, let's scale it down to 0.1. Or if you want, pwede rin i-smaller pa natin, no? Kunwari 0.05 for the arrowhead size. So it becomes a smaller line, no? But I think the 0.1 works well, no? Okay? So that's SD. Next is, i-project ulit natin siya onto, kasi complete all views to, we need to project SD dito din sa view na to. Okay? So, I'll go back to my construction layer. Project ko backwards ito. This is along KL, no? So, ipo-project ko papunta sa KL. This one is along RS. So, ito siya, or ito yung connecting to RS. So, ito. And I can now connect the two. And of course, this is the final answer, no? So, change natin to final answer. And I'll say SD din to. Ito mukhang may malaking space naman, so I can just type SD in final answer. That's my SD. Okay? Now, the question was, ano yung... Ito? Hindi to true length to. SD to, SD. SD. Parallel ba dito? Pwede natin check. Pero it should be parallel, no? Yung distance? Perpendicular sa KL. Kasi di ba perpendicular for perpendicular lines, dapat true length yung isa, which is in this case si KL kasi yung true length. So it should be perpendicular. Pero kung tama ang ginawa natin, this also should be parallel, no? Yan, parallel din siya. Pwede nyo rin ganun, no? You can also do that. Instead of making it perpendicular to the true length KL, pwede rin naman parallel to the ARP-FRP line because SD is true length here. Okay? Both will give you the same answer. Ito pa rin yung same orientation yung mangyayari. Okay? Right? So, if you are asked the question, how many millimeters is this? Since this is not scaled properly, no? Wait lang, This is, ang distance niya is 7.7. Ano actually ito, no? Naka inches to. So, for us to measure exact distances, pwede natin gawin is, try to create a rectangle using etong endpoints na to. Meron kasing siyang marker dito sa kano, no? The markers are actually the ends of the paper. So pwedeng you get one endpoint, ito, connect it with the other marker here. Ganyan. So you have something like this. So yung outside is actually your paper size, no? So para scaled siya correctly, ang pwede natin gawin is we can select everything. Press SC for scale. Press enter. Tapos specify the base point. Ito, we'll make this as our base point. Then gagawin natin is we'll do reference line. So R, press R for reference. Enter. Tapos yung reference line natin is this one to this one. Papunta dito. Yan. And now we input a number. We know kasi na this line, itong baseline, should be 210 millimeters. So if you type in 210, it will scale everything. And kaso na-lock pala yung isang layer. Now, let me do that again. I'll unlock the given muna para pwede siyang mag-scale din. So ang gagawin natin is we select everything. We press SC for scale. We choose the lower left as our base point. Tapos, we press R for reference. Or you can click the, pwede naman i-click nyo yung chip doon sa baba. Pero I'll just press R for reference. I'll specify this bottom edge, ito, from here to here. That's my bottom edge. This one. Tapos, ang gagawin ko is, because I know the length, the supposed length of this baseline, I know it's 210. Kasi si A4 is 210 by 297. So, I'll place in 210, like so. Tapos, mag-scale up lahat. So, ngayon, yung measurements ko will now be accurate, no? So, whatever measurements I make, if I make a measurement like, for example, ito, if I make a measurement here, this is now in millimeters. Kasi naka-millimeters na yung scale ko na such that ito, 210 millimeters itong baseline ko. Okay? So, I'll just lock this again. So, now, if I were to measure this one, I can do MEA for measure geometry. And I'll measure this length of the line. And ang sabi daw, it's 6.407. If you want to be fancy, pwede naman dim yung gamitin natin na command, no? Dim. And select this one. Pero we'll change the M text here. Instead of 0.18, lalakihan natin, no? Magiging, you can choose 1. Tama, 0.5 siguro. 0.5? Oh, maliit pala yung 0.5. 1 nga ata. 1. 1 is good enough. So, pwede ganyan. Pwede namang gamitin yung dimension command para makakita yung uh, distance ng line. No? If not, if you don't want, just use MEA. Tapos measure nyo lang. May lilitaw na number dyan. It's 6.4071. So, now you can type in what is the final answer. Type nyo lang dito. 6.401. No? Tapos, tama ba yung point? Masyado maliit. Let's do text. 6.401. Etong point 1 was appropriate for the scale down. So since nag-scale up tayo, I think gagawin nating 1 siya. Press Ctrl Enter. And masyado maliit pa rin yung 1, no? Maybe 5. Masyado naman malaki. I think 3 ata. 3 nga ba? 3. 3 is good. Medyo malaki nga eh. 2.5 ata to. 2.5. Ayan. Oop. Nag-snap siya. So, I can Control F. And so, this should be what the final answer should look like. Ayan. Lipat natin to final answer. Okay? So, yan yung answer natin for the first problem, which is 6.401 yung millimeters. Okay? Pwede naman, if you don't want to scale, then you can just do ratio and proportion, no? Yung original kasi naka-inches yon, so 7 point ano. So, pwedeng kung mineasure nyo to using the original, you just convert it from inches to millimeters. Okay? Pwede din yon. You can do that, no? Nagets ba? So, kunwari, i-control Z ko lang lahat, no? Medyo malayo-layo yung control Z yun. So, kunwari, you don't want a scale. So, ang measurement nyo dito is, this is 8.5. 8.5 is the inches na measurement for A4 size. So, whatever you measure here is in inches. So, kunwari ito, if I measure this one, MEA, I'll measure this distance, 0.2593 siya. So, that's 0.2593 inches. Then, you just convert. Ano ba yung 0.2593? Gamit tayo. 0.2593 times 2.54, di ba? To get millimeters. Times 25.4 to get millimeters. That gives us 6.58. Medyo malayo doon. 6.40 yung nakuha natin. No? 2593 2 inches. 2 inches 2 millimeters. 6.58. Bakit 6.4 yung nakuha natin? 8.A4 size in inches. Okay, gets ko na. Kasi ang in inches, it's supposed to be 8.27. Kaso 8.5. So mukhang, hindi ata A4 tong paper na to, no? This paper is 8.5 by 11. That's short band letter size, no? Tama? Paper 8.5 inch by 11. Ito nga yung letter nga ata. Yan, no? Letter size nga siya. So, dahil letter size siya, then we'll have to scale it differently, no? Ano ba ang letter size? Letter size in mm. 216 by 279. Huwag na natin i-scale, no? Gawin na lang natin, retain natin na inches siya. Convert nyo na lang. So, ito, this is 0.2593 daw na inches. So, you just convert it into mm. 0.2593 times 25.4 gives you 6.58. So, ang correct answer should be 6.58. Ano yun? Maglalagay ng arrow. Arrow is placed through M leader. M leader or MLD, pwede yun. M leader or MLD. Tapos yung first point is kung saan mo gusto idikit yung arrow. So, yun yung first point. Yung second point is kung saan mo gustong parang hanggang saan yung arrow. The next is you just type in whatever text you want to type. So, kuwari SHD. Yan. MLD for M leader. Okay? So, 6.58 yung sagot. Pero if you answered 6.4, okay lang. Okay na siguro. Pero 6.58 yung sagot if ano yan? Ba't iba-iba? Sige, para matest. Measure nyo yung distance dito. Measure nyo yung distance ng sa baba na portion. 210? O, dito ba tama sa'yo? 6.54 dapat yun. Patingin? Dito yung measure. Mali yun kasi dapat ito from here. Doon sa, kung tingnan nyo sa bottom right at upper left, may parang markers dyan. Gawa kayo ng rectangle to connect the two. Yun yung actual paper size. Ito border pa lang to eh. Meron. Okay? So, ganun, no? When you're scaling, dapat yung actual paper. Kasi ito, border pa lang yan eh. Doon sa, di ba, pagka piniprint natin yung plate, di ba ganito siya? Notice how, ito yung may border siya, no? Pero yung actual paper is a few millimeters away from the border. So, yung plate na binigay, meron siyang marker dito sa bottom right and sa upper left. Pag-connect nyo lang yun, and that should be good. Pero okay lang. Usually naman, pag ano, no, for this, ito mga ganitong problems wherein you are asked the actual distance, usually it's printed on paper, no? So, para pa din yung directly measure using your rulers or triangles. Pero ito, enough na tong ano for CAD, enough na yung na-measure nyo, napakita nyo yung actual na shortest distance. Okay? So let's try the other ones. Ito naman is determine all the common perpendiculars between the given lines and you complete all views. So if you have this one, the easiest way to do this is you have to do the common perpendicular. Kasi ito, these are skew lines that are shown perpendicular to the fold line, no? So easiest way to do this is to create a line that is, or create an auxiliary reference plane. You can create any auxiliary reference plane, pero the easiest way is to just create a vertical reference plane, no? So you can create it from HRP, or pwede din naman you create it from FRP. Doesn't really matter, it will give you the same solution, no? I'll just create it from HRP. Pero if you created it from FRP, same answer lang dapat yung lalabas. Okay? And I'll just name this let's name this X. To the left is HRP, no? HRP. To the right is ARP 1. Hindi ko na kailangan i-label with 1, no? Kasi exact naman siya. I'll just move this a little bit. Yan. Okay? Now, project lang natin. Go with construction layers. So, it's just a matter of projecting everything, no? Tapos, basis for distances is 2 views away. So, dito sa FRP yung basis natin. Okay? So, let's do, this is location of B. I'll trim this down. Location of C is this one. Sorry, A pala. A, I mean. Let's trim this. Location of C is this one. Oh. Next is location of D. Perpendicular distance ulit. D is this one. Next is E. So, I'm doing this alphabetically, no, para hindi ako malito. E. Next is F. Again, just trimming it. Then we have H. H and B share the same, I don't know. So, I'll just do a point para lang makita. Tapos, lastly is G, no? G is this distance. So, let's trim that. Okay? So, ngayon, let's just connect it. A and B is A and B. Oh, no. Let's use a final answer. Layer. A and B. C and D. Then, E and F. E and F. And lastly, G and H. Ito. Okay? And we'll probably need to label, no? Label natin B, A, saan si C? C, D, then, ano ulit tong line na to? This is G, di ba? Ano, sorry, H. And lastly, ito si G pala. And this one is E. Kompleto na ba? A, B, C, D, E, F. Kulang ng F. F, G, and H. So, ang gagawin lang natin is to create the perpendicular lines. We know that this is in point view. Yung common perpendiculars na to is in its point view. So, dapat ito, if we create a projection line from the point view, this one, this is between, between EF and GH. So, EF, this one, and GH. So, dapat yung line should be this one. Ito siya, no? EF and GH. Yan. Next is, I'll do the construction lines first na lang muna. Next is AF and, AB and EF. So, AB and EF. So, ito. Next is, yun lang yung dalawa, no? Merong, projections. Tama? May common perpendicular. Ito, kailangan mo i-extend para magkakaroon ng common perpendicular. So, let's extend this. We'll just extend this one using a, yan. So, that's where the common perpendicular of A, B, and C, D should be if A were extended. No? Okay, so parang ganito. I'll just trim this down. Malayo yung? Malayo yung C? Ayaw nga. Sorry. Thank you for the correction. No? Dito lang pala si C. Mukhang hindi ko nakuha. Si C lang ba yung mali ko? C lang, no? Thank you for the correction. Ito dapat si C. Ayan. In this case, hindi na kailangan mag-extension pala, no? So, I'll just trim it para mas malinis. Trim. Let's type in C. Yeah. So, let's create. Ito naman si CD and AB, no? Sorry, CD and GH. So, CD and GH. CD, nandito. Tapos, ang last is CD and AB. Okay? Tapos, finalize lang natin yung kailangan i-finalize, no? So, this one, CD, GH. So, CD to GH. Ito naman is AB and EF. So, from AB to EF. And lastly, meron pa isa. Nag-meet sila, no? Si EF to, and is this CD? CD, no? EF to CD. Ito siya. Okay? So, EF to CD is this one. Ito naman is AB and CD. So, AB and CD. Kompleto na ba natin? These are 1, 2, 3, 4. 4 lines taken 2 at a time. 5 ba lalabas nun? 1, 2, 3, 4, 5. Hindi nag-intersect si AB and GH. Tama? So, 6. Alam ko 6 dapat eh. Kung 4 lines taken 2 at a time. Tama ba? 4C2. 6 nga. Tama yung ano, no? So, kasi we are taking 2 pairs at a time. So, 4 lines taken 2 at a time is 6. So, dapat 6 distances to. Pero since si GH does not physically interact with AB, but if we want to, pwede nating i-ano sila, no? Extend. So, find their sort of theoretical na shortest distance, or their theoretical shortest distance should be when we extend. So, ito siya. Yan. And let's extend this a bit. Yan. Mahanap natin kapag in-extend natin siya. That's AB and GH, diba? Ito siya. We can also find it, no? But now, it's sort of theoretical siya na, ano, common perpendicular. Pero pagka pinagawa ko sa inyo to, hindi ko na ipapa-extend yung mga lines, no? So, if they're not physically, or if you don't, or if they are not overlapping, hindi nyo na kailangan hanapin yung common perpendicular between them. Okay? So, only find the common perpendicular for those lines that are in space are actually overlapping. Okay? I'll just show this to show that this is a theoretical, no? Na, ano, or yung parang, ano, imaginary nila if the lines were to be extended. Okay? Ano, nag-overlap nga sa kabilang line, plane pa, viewing reference plane. Okay? So that's how you do common perpendiculars. And lastly, we have 20 minutes left. Kaya-kaya natin to. Which of the 3 lines is nearest to each other? Use only 2 additional views. So, ang gagawin natin is we can do a parallel plane method, no? Wait lang, ha? Sige, we'll do parallel plane method, pero Parang hindi appropriate yung parallel plane method, no? Kasi the parallel plane method uses two additional views, pero that's comparing only two lines, no? So, pangyayari is, because there are three unique lines, we'll have to create four additional views para lang if we wanted to use the parallel plane method and get the shortest distance from there. For this case, I think it's more appropriate to use the point view method. Kasi if you look at it, XY is true length here and AB is also true length dun sa kabila. So, pwedeng i-point view natin si AB, then find the short common perpendiculars there. Then i-point view din natin si XY to find the common perpendicular. So, ang total additional views lang na pwede magawa natin is two additional views. Okay? So, what we can do, this one, let's just extend this. Again, we're extending para makaka-create tayo ng yung additional view dito sa taas. I'm thinking if this is the best solution. Kaya ba natin i-simultaneously? Parang ito na nga yung best solution. Okay? So, then let's create a perpendicular reference plane. So that ang lalabas dito is now a point view si AB and with the XY and JK projected. Okay? I'll have to make this closer, no? Kasi I think lalagpas ako kung masyadong malayo. So I'll make it a little bit closer dito para pasok pa rin siya dito, no? Okay? Let's always label your reference planes, no? So this is ARP1 and FRP. Okay? Move back to the construction lines layer. Okay. And then XY. X and Y. So, tapos, two views away, 1, 2. This one. Just make sure you're measuring the perpendicular distance, no? Kasi what I made is parang pwede siya makuha yung intersection, which is not what I'm looking for. I'm looking for perpendicular distance. When you're doing things like this, no, especially when lines are too close to one another, what I suggest is you always zoom in, no? Zoom in nyo lang para sure kayo na yung tamang distance yung makuha nyo. So this is point J. And this is point J, then this is K. K is this distance away. Medyo lalagpas na eh. AB is this distance away. So ito magiging point view na talaga si AB. Which is this one. And as early as now, let's mark it with a point, no? Point view. Then, X and Y na lang, no? X is this distance away. And lastly, Y is this short distance. Okay? So I should have change layers. This is JK is this one. XY is this one. Okay? That's JK and XY. And again, let's just label J, K. I can move it a little bit. So ito naman, X to, no? X. Is it X? X. Tapos ito, Y tong sa baba. Tapos ito, this one was AB. A is closer, no? So AB shown in its point view. Okay. Now, we can measure the shortest distance. Gawin natin is, let's measure AB and JK, which is this one. And this one is for AB and XY naman. So let's do SD. Let's just say SD1. And ito naman, I'll use an M leader for this, no? MLD. I'll say SD number 2 naman to. Oh, masyado malaki. 0.1. SD number 2. Okay? I-adjust. Probably ganyan na lang. SD number 2. Okay? So now, ang kulang ko na lang is yung distance between X, Y, and JK, no? Okay? So, to get that, we take the point view of XY. And from here, if we get the point view of XY, we can also confirm the distance between XY and AB, no? If it's the same as this distance right here, SD1. Okay? So, let's go back to construction layers. I'll just extend XY. Tapos, I'll create a perpendicular reference plane. And I think I can be more generous sa space, no? Since medyo malaki naman yung space dito. So, okay siguro to. Ganito ang distance. And again, always label the planes. This is ARP2 na, no? And before it is PRP. Okay? So, PRP, ARP2, PRP. Then, let's use construction lines. Sorry. Tama. Let's do projections. So, I'm projecting this. Point J is here. Point K is here. Perpendicular. Point AB is... point A, sorry, is here. And point B is... this one. Okay, let's measure distances. 2 views away, 1, 2. So, dito tayo magme-measure. And 2 fold lines away, 1, 2. So, let's do XY first. So, X is this distance, which is the same distance as Y. Which makes it such that this now becomes a point view, no? And this point view is the point view of XY. Right? Now, let's measure si J is this distance away. Again, I'll have to zoom in para sure akong tama yung mini-measure ko. J, let's trim it down. Ay, mali. Ano yung tinrim ko? Oh, tama pala. Tama yung tinrim ko. J is a far distance away. No? Next is A. Let's measure A. A is this distance. Next is B. Is this distance away. Trim. And lastly, K is this distance away. Hopefully, tama yung ginawa ko. Tama naman yung pag nagkunan ko ng distances. No? Malalaman natin mamaya. J and K. So, let me connect. J connects with K. Then B connects with A. Here. Okay? Medyo malapit si XY and AB, no? Para may mali. Ulitin ko lang. Let me just double check. Mukhang mali yung A na mineasure ko, no? Mali nga yung A. I think dito, ito yung mineasure ko, no, from this fold line, which is wrong, no? Kasi it's 2 fold lines away, so it should be from this fold line. A is wrong. I should have measured it from here, no? Now, this makes a lot more sense. Let me just extend the line. So, lipat ko lang dito. Yan. This is correct. Kasi, this SD2 right here should be the same distance as this one. Okay? So, let's make our shortest distance ulit. Or common perpendiculars. Ito, we just make it perpendicular. And this one also perpendicular to this line. And zoom in. This is now, I'll use text. Make it parallel to this one. I'll say, ulitin ko, text. Make it parallel to this one. And I'll say SD3. Shadow SD3 na. This one is SD2. Move ko lang to konti. This one is SD2, no? And I'll use an M leader ulit, MLD. Measure it from here. This one is SD2. Make this 0.1. Tama? SD2 siya kasi same distance lang to eh. AB to XY. This is also AB to XY. And just to make it clear, let's label everything. This is AB. No, not AB. This was XY. Tama. X is closer, so XY siya. So XY shown in its point view. This one is A. Ito nga ba A? Tama. A. This one is B. And lastly, J to. And this one is K. Okay? So tama? SD2. Same distance. So if we did it correctly, if I measure this one, MEA, measure this one. This is 0.248 ang SD2. If I did it correctly, should be 0.248 as well. 0.2629. Hindi ganun ka-accurate. Hindi ko alam kung may mali akong ginawa or the problem. Yung nakuha nyo ba exact? May nakakuha ba? May nakatapos ba muna? Ko lang kung hindi ko lang na-snap na maayos, no? It could be... Ay, okay. Alam ko na kung bakit. Hindi pala. Mali nga to. No. Dito dapat to. Ay, mali yung pagka-point view niya. Dapat eto siya. Tama yung line, no? Yung pag-mark ko ng point. So, eto magiging mali to. Kailangan, ngayon. So, that's the importance of zooming in, no? Para ma-make sure dapat na correct yung lines nyo. Let's measure it again. MEA 0.26 0.2629. The same na siya. Okay? So, ayan, same lang. Mukhang skill issue ko lang yun. Okay? So, same ba? May nakakuha? In millimeters, so we'll have to do some conversions now. Convert ko ba ngayon? Sige. Gamitin natin to. 0.269. 2629 yun, di ba? Inches to millimeters. 6.68. So, sulat natin dito. AB and XY yun, di ba? Next is, I can use a circle tool as well, no? 0.55. 0.55. 13.9. Parang 14 ano? 13.98. Ano ulit yun? That was AB and, ito yun, di ba? Mineasure ko. AB and JK. So that was 13.97. Tama. And lastly, yung SD3, which is this one, siya ata yung pinaka malaki. 0.6396. 0. Let's just say 64. 16.26. So the largest distance is 16 point. Okay? Largest distance 16.26 between JK and XY. Okay? Final answer should look like this. Pwede siguro nating i-ano. Yan. Mas manipis. Para mas accurate, no? Okay? Thank you, Gab. Pwede ka na hindi pumasok.
Pero nagawa ko ng first. Pinag-compare lang nila yung ano dito. Saan siya para? Or arbitrary?
Okay?
Sir, yung ERP to ERP, arbitrary lang dito.
Ito? Hindi. Perpendicular. Para maging point B.
Sa X. Sa XY.
XY. Para maging point B sa XY. Kasi true length kasi dahil dapat pala binart natin. No? Dapat part ng final answer should be, dapat minark natin to. This one. We should have marked this with true length. No? Tama? Tapos ito naman, ito din true length to. At yan yung sagot natin. Okay? Yan. Again, part to sa mga chine-check, no, yung labels. So, na-return na sa inyo yung, yung plate 1. So, may marks na nilalagay si Gab doon na kung hindi nyo nalagay ng proper labels, kumari yung points, or hindi nyo nasulat na ruler siya, or point B siya, or especially mga ano rin, mga itong reference links, yung kailangan natin nililabel siya. Okay? Okay, it's 4:58. Sakto lang. You can stay if you want to complete it, no? I'll just stop the recording. Ito nga.